We're asked to write the prime factorization of 663. 3 goes into 663. So we can write this as 3 times 221. Now it's not really clear what goes into 221. We could try lots of things. But we just don't know. So we have to try some primes. So let's take 221. 2 does not go into it because it's not an even number. 4 and 6 and 8 and 10 and 12 and no even number can go into it. So now let's try 3. 3 does not go into it because the sum of these numbers is 5 and 3 doesn't go into 5. 5 doesn't go into it because it doesn't end in 0 or 5. 6 can't because it's even. It's not prime. 7 doesn't go into it because when I divide, it just doesn't go in evenly. So 7 doesn't work. The next prime is 11. 11 goes into 22, so it would go into 220. But 11 won't go into 221. The next thing to try is 13. And we get 17. Exactly. So this is 3 times 13 times 17. Now with a calculator, this work is easier. Still, that's quite a bit of work. That's pretty tough to break it apart. Finding the 3 was pretty easy. The 13 times 17 is not very easy at all. So on June 1st, a particular day, the grass is cut and the shrubs are trimmed. And then every 6 days after that, the grass is going to be cut. So these are the days after that where the grass is going to be cut. And we could go on for a ways, but why bother? Because every 16 days, the shrubs are going to be trimmed. And we're looking for a match, so it looks like 48 days from now will be the first time that both happen on the same day again. So that's 48 days. This is probably the most basic way to find that, but there's lots of ways of finding this value. It's called the least common multiple. When you're not dealing with fractions, it's called the least common denominator when you're dealing with the denominators of a fraction, but it's the same piece. One way of doing this that we've found is you can take the prime factorizations of the numbers involved and you can take the most of each kind of prime factor in either one of these. So in terms of 2's, this has 4, this has 1. So take 4 of them. In terms of 3's, this has 1, this has none. So take 1 of them and multiply them together. And that is the least common multiple. This is 16 times 3, and that is 48. So there's another way to get 48 or 48 days. Problem 77, we're asked to find the greatest common divisor or the greatest common factor. They're kind of the same thing, and there's many ways that we know how to do this, but we're asked to use a different method called the Euclidean algorithm. And the Euclidean algorithm amounts to cleverly doing a series of divisions. So if you're trying to find the greatest common divisor, greatest common factor of two numbers, take the smaller of the two and divide it into the bigger of the two. Don't use decimals, use remainders. So this goes in once, and the remainder's 30. And now what you do is you take the remainder and you divide it into the divisor. This is a cyclic process. You can do quite a few steps. So we take the remainder and divide it into the divisor, and this goes in 5 times, and the remainder's 0. Now if we were to try to take this remainder and divide it into the divisor, you can't divide by 0, so this is impossible. So once you get a 0 down here, and you will always get a 0 eventually, then whatever the divisor was that matches that 0, that turns out to be the greatest common factor. 30 is the largest number that divides into 150. It happens to go in 5 times exactly. And also divide into 180. It happens to go in 6 times exactly. So the greatest common divisor or greatest common factor of these two numbers is 30. And we found that using the Euclidean algorithm. So we're to use the procedure described in problem 83 to determine how many factors 60 has. We've already learned this procedure once before, so it should come back pretty easily. 60 is 6 times 10, 6 is 2 times 3, 10 is 2 times 5. So in the prime factorization of 60, we have 2 times 2 times 3 times 5. That's 2 to the second times 3 to the first times 5 to the first. When we try to use these pieces to build all the factors of 60, we have 3 possible choices for the 2's. We can choose 0 of them, 1 of them, or 2 of them. So this gives us 3 possible choices. In essence, it's this exponent plus 1. Here for the 3's, we have 2 possible choices, none of them or 1 of them. In other words, it's this plus 1. It's the exponent plus 1. And here we have choice of putting in 1 5 or no 5's. Again, it's this exponent plus 1. So using this trick, 3 times 2 times 2 is 12. That means 60 is going to have 12 factors, and that's the answer to part A. Part B is to list all the pairs of factors, all the numbers that are factors of 60, and to show that it is in fact 12 of them. So we have 1 times 60 and 2 times 30. Notice they come in pairs. 2 divides into 60 30 times. 30 divides into 60 2 times. We have 3 times 20, we have 4 times 15, we have 5 times 12, we have 6 times 10. And these kind of count themselves. 1, 2, 3, 4, 5, 6. That's 6 of them. Here's 6 more. That's the 12 factors of 60 that we predicted here. And we're done.